Hello, I'm Inthavong, and me, Sahn, and Luke have working together on our project for about a year now. Our goal is to create a bird that could fly. We believe that this project would give us perspective into what we love so much about engineering. While we unfortunately could not create the bird with our current set of skills, we pivoted into making a plane that we are still proud of. And I believe this project will give us a good foundation into future projects that we will create in the future as we become better engineers. Firstly, we decided to create a bird because the idea of something flying was very inspiring to us. Personally, I've always been fascinated by planes and the like. The reason why we chose a bird specifically is because it seemed very unique and extremely challenging. To begin our project, the centerpiece was a 3D printer we bought over the summer. This 3D printer was meant to create nearly the entire plane, from the body, the gearbox, to the extra parts for our servos and motors. The early phases of our project consisted of solving the problems of turning rotating motion into consistent flapping motion, all while keeping the system light, compact, and suitable for our very tight payload restrictions. While we successfully modeled the gearbox, the limitations of our 3D printer and the bird itself made it difficult to fabricate the gearbox in real life. Issues such as parts snapping over the stress and prints failing over the small margins of error made us pivot off the bird. Our attempted solutions included slower prints, different printing methods, and new printing materials and new models. Unfortunately, none of these solutions provided satisfactory results, as integrity and weight were still massive issues. Other issues that plagued the bird was the body itself and the challenges that came with trying to 3D print the whole thing. The main problem was combining the gearbox, which had to be large to be strong, with the body, which couldn't be large enough to fit the gearbox without going over the weight limit. Any solutions that would try to make the gearbox smaller would result in the gears breaking due to the stress of the motors. And we couldn't pivot toward another method of flapping because other methods were either 1, too large, or 2, ran into the same issues of breaking under stress. We attempted to solve the problem of space with an open top body, however it still wasn't strong enough and had weight issues. This conflict led us to reconsider our project and pivot towards a propeller-powered plane. The first iteration of our plane was horrible. First, the front was unsecured, so whenever the plane crashed into the ground, the front would cave in, destroying the plane. Second, the plane was thrown. This was incredibly unstable and was not a consistent way to take off the plane. Third, the propellers were way too small and could barely supply enough lift to fly the plane. Fourth, the wings did not have enough of an exaggerated teardrop shape, which led to too much drag and not enough lift. Even though we had many more issues than I mentioned, we slowly solved each one through test flights and failures. To solve the problem of the front being unsecured, we added a strong, reinforced front made out of layers of foam and board, and then secured the motor at the front with screws instead of zip ties like we were originally doing. Next, we added wheels for our grounded takeoff. Even this had issues though, as we had to go through multiple iterations of the wheels. Our original ones were wheels from Home Depot and attached with screws, cardboard, and foam to keep the weight as low as possible. However, these wheels were very rough on the ground and often got caught in the bumps on the road. These led to unstable takeoffs. We switched to an aluminum frame with sponge wheels after Mr. Barrett suggested them. In addition to giving a more stable takeoff, it gave our plane better chances to survive after a crash, as it wouldn't dive straight into the front anymore and instead hit the wheels. Our next problem was our propellers. They were way too small and way too slow and could barely provide the lift we needed. To solve this, we need to add new larger propellers and buy a better battery to provide more power to the motor. Lastly, our wings needed to change because they were way too thin. In some of what we learned about wings, we learned that the reason a plane flies is because wings create a zone of low pressure, faster air above its wings, and an area of high pressure, slower air below its wings. Just as blowing air over the top of paper causes it to rise up, air going over a wing causes the plane to rise up. To fix the issue with our plane, we realized that we needed to create a larger angle at the front of our wing to create more lift. That was a quick summary of the larger issues we faced along the way and how we solved them, but that wasn't all of them. Here's a quick rundown of some issues we solved, but were too small to warrant a full explanation.
Quick issues that we solved. We did not know there were so many tiny complications about charging LiPo batteries. As a whole, we did not have much information about LiPo batteries, which caused a couple handicaps, but after learning more, we bought a new battery and charger, which pairs perfectly with our project and provides more power to our motors than the previous batteries, which died after a couple usages. Our attachment of the wheels sucked, so we printed L braces. The older version of our plane was built with straight glue instead of solid attachments, which transferred a lot of the weight onto the bottom of the plane, causing a weird balance. Along with that, switching to L braces made it easier to modify the plane as there's no glue residue left when using screws. Our attachment of the control surfaces sucked, so we attached hinges. The flaps and in-air control surfaces were done by tape as a quick test method before with our older planes, but we designed and 3D printed flexible hinges to have better stability and more force with the turning of the bird, as the tape was kind of floppy in the air and wouldn't really result in good results when turning the plane. With the hinges being a more solid support, this helped the in-air control of our plane. Our wings didn't have enough lift to take off, so we changed the settings on our controller to allow for opposite and similar wing motion. To accommodate for bad liftoffs, we changed the settings on our controller, allowing us to switch from our main wing flaps being in opposite motion, allowing left and right, directional turning, and being in similar motion, allowing up and down motion. So we could switch between in-air control and on-the-ground control. On-the-ground control allowing takeoffs to be done having our flaps pointed down, and in-air control systems having them opposite, allowing for left and right turning.
During this project, me, Sahn, and Luke crashed our plane a lot of times. However, each time we walked over to the crash site, we picked up our broken wreckage of the plane, and instead of quitting when we saw our hard work turn to ruin, we looked at each other and asked, what did we do wrong and how do we fix it? Even though it was very difficult to start over again after each crash, we built again with more knowledge than we did last time. And eventually, with our new knowledge, we will get it right. Thanks for watching.